Alright, so here we know that the absolute value of a has to be greater or equal to a. We know that because we're taking the positive, and a could be negative. Alright, so knowing that, let x and y be two real numbers, use the above result to prove the triangular inequality. And begin with the left-hand side as minus the right-hand side. Okay, so squared. So if I begin with x minus y, all squared, we know it's positive, so I could do this. So all that squared minus all this squared, and again, alright, all that squared. Okay, if I start with that, what do I know about this? Well, I know they're both in absolute values, so I don't really need the absolute values once I square anyway, because it's positive anyway, so I can rewrite it like this. Again, and this one, let's just rewrite it first. When we square, what do we get? So here we're getting x squared minus 2xy and a y squared. And here we're getting minus, well, that's going to be, I'll do it properly. That squared, we're going to get minus, so plus 2xy, which is the same as xy. In one absolute value, we'll do that in a second, plus this one squared. Alright, so what do we get? We get x squared minus 2xy plus x squared, sorry, y squared, and I've changed it to an x. There we go. Now, absolute value of x squared is the same as x squared. Here we've got 2xy. And absolute value of y all squared is the same as y squared. We don't need the absolute value if we're squaring because we know it will become positive. So you can see the x squared will cancel with minus x squared, y squared. Oops, that should be a minus because I've written something down incorrectly. Yes, I have. Oh no, I haven't. Yeah. So I should have had, so when I square this I get a positive, but it's minus times that. Apologies. So that should be a negative there. So the y squared will cancel with negative y squared. So y squared minus y squared. So what's actually left? We have a 2. If I put this first, this is a 2xy, and I've also got this one minus 2xy. Now, what do we know about that? Well, we know that that has to be greater or equal to 0 because the absolute value is always just up here is greater or equal to xy. So we know that. So we could have also included a step where it's 2 outside of xy minus absolute value of xy minus xy. But yeah, so we know that. So let's go back. So now we know this whole left-hand side, squared minus right-hand side is greater or equal to 0. So if I do a little whiteboard magic and say we know that that is greater or equal to 0, we just showed that, and then rearrange them again. So we don't need absolute values because it's squared, and if I put the other bit on the other side, again, we don't need absolute values because it's squared. So I've got this squared. And we can keep that inequality because we're just moving that around, and we can keep the inequality when we square root. So I could have kept that, couldn't I? I could have kept that in. And I could have kept that in. Doesn't matter if I keep it in or not. So when we square root, because they're both positive, so we're all good. When we square root, we still keep that inequality. So we're just square rooting both sides and getting back to what we want to prove.